Hey guys, we are going to start our unit today on absolute value equations. We are going to solve them and graph them and talk a little bit about them. So today we're going to start off with solving some pretty basic ones. So I know that in elementary school and sometimes middle school, a lot of teachers have their kids just remember anytime you take the absolute value of something, it becomes a positive number. And yeah, that is true. So if I asked you to take the absolute value of negative 13, you would indeed tell me that the answer is 13, but I want you to know why. And the reason why we say that it's a positive value all the time is because absolute value is defined as the distance away from zero. So if I have the absolute value of negative 13, I'm saying negative 13 is 13 units away from zero. And that's why we call it a positive number. Now, Matilda showed us that the dad told us if we went backwards with the car or whatever, that we could kind of go backwards with our mileage. But if we think about it, whether you put a car in reverse or in drive, you're going to be traveling a positive distance. So that's kind of what I think about when we're doing absolute value functions. So I have this one here, the absolute value of x equals 5. Now that means that if I start here at 0, I can travel to the right 1, 2, 3, 4, 5 units and end up here at the number 5. Or I can start again at 0 and travel to the left 5 units, 1, 2, 3, 4, 5, and end up here at negative 5. So when we see something like this, if you want to graph it to solve it, you're welcome to do that. But the algebraic way to look at something like this is to say, okay, well, x can equal positive 5 because I can travel to the right 5 units. Or x can also equal negative 5 because I could have traveled to the left 5 units instead. All right, so our first example here, the absolute value of x minus 5 equals 7. So when we're taking that distance, we can travel to the right 7 units or we can travel to the left 7 units. So if we want to solve something like this algebraically, we're going to break it up and say x minus 5 can equal positive 7, traveling to the right, or x minus 5 can equal negative 7, which would be like us traveling to the left of 0. So when we look at this, then you just solve it as though it's two separate problems. We've done OR problems before, and you solve for x on either side, acting as though it's two separate problems. So in this one, to get x alone, I'm going to add 5 to both sides. Therefore, x equals, not that, 12. Or on this side, if I add 5 to both sides, I'm going to say x equals negative 2. So x can equal 12 or negative 2 for this particular situation. All right, why don't you go ahead and pause me and give this one a try on your own. The absolute value of 5x minus 10 equals 45. I'm going to go ahead and start it. 5x minus 10 can equal positive 45 if we travel to the right 45 units, or 5x minus 10 can equal negative 45 if I were to travel to the left that many units. And then we solve it as though it's two separate problems. So I'm going to add 10. 5x equals 55. It's ugly 5. And then I'm going to divide both sides by 5 to say x equals 11. Or I'm going to add 10. 5x equals negative 35. And divide by 5 so x can also equal negative 7. All right, you can go ahead and pause me again if you'd like to try this one, but please come back for the answer because this one is a little bit different. On this one, if I go ahead and set it up, I've got 3x minus 2 equals negative 13, and 3x minus 2 equals positive 13. I'm going to add 2 to both sides, so 3x equals negative 11. Divide by 3 to say x equals negative 11 thirds. Add 2 to both sides, 3x equals 15. Divide by 3 to say x equals 5. So we see our answers are here. Now what we do need to pay attention to though is the original problem and making sure that our answers make sense. So it's always a good idea once you have your answers here to be able to plug them back into the original problem to check and make sure that they work, check to make sure that they make sense. If you want to use a graphing calculator to do that, you can find absolute value bars underneath the math category, and then you hit the side arrow once, it'll say ABS. Now, if you take a look at this problem, and if you plug in those original values to check to see if they make sense, I'll start with 5 because that's the easy one we could do in our head, okay? So I have the absolute value of 3 times 5, 15, minus 2, and I need that to equal negative 13. Well, 15 minus 2 is 13, and if I take the absolute value of 13, well, that's 13, and last time I checked, 13 does not equal negative 13. The same thing is going to happen when you try to plug in this other one. Now, a lot of work could have been saved here. A lot of time and effort could have been saved. If you look at this original problem right here, there is a big fat red exclamation point, arrows pointing that say, stop, don't do it, there's a problem here. That problem is this negative sign right here. Remember, the absolute value bars are the distance away from. You cannot say that the distance away from 0 is equal to a negative value. We can't travel a negative distance. So an absolute value, the number of an absolute value, is never going to equal a negative number. And so therefore, immediately, you could have saved all this work and said the answer will be no solution. That's it for today. I hope you guys have a good day and the best of luck with the homework. If you need me, you know where to find me on email or in Google Hangouts. See you later.